if you watched the video already, the lecture video, you somehow have an idea of how the DNS works, and I have some detailed discussion about the different aspects of DNS, the zone file, the zones, the domain, etc., the theoretical concepts. So here we're going to talk about some of the details of low-level details of DNS, and in order how to perform an attack. So press the wrong key. Okay, so to start with, let's review the DNS packet format. So remember that DNS is an application layer protocol whose main job is to retrieve the IP address given the domain name, because the domain name is easier to remember compared to remembering the IP address. But in the networking world, in the TCP/IP network world in particular, it is the IP address that is used to identify a node in the TCP/IP network. So essentially, DNS is an application layer protocol. So in DNS, first, there are two types of packets. We have the query and we have the response or the answer. And this is the format for the DNS packet. And remember that DNS uses UDP. So UDP as the transport layer protocol. UDP is connectionless, unlike in TCP, wherein you have to have a three-way handshake, connection establishment, data transfer, and termination. In UDP, it just send a request and then a response may arrive or it may not. So the query is, the format for the query packet is like this. So you have the header and we have the question section. We'll describe the contents of this in the next slide. And then for the response or the answer section, we have also the header, the question. So that means that in the answer question, the question section is also included, right? So except duplicate here. Then you have the actual answer section, the authoritative section, and then you have the additional section. So remember that we have a DNS server, right? So these are the main components or main parts of a DNS packet. So let's dissect these packets format. So the first is the header. So what is the format of the header? So the header is composed of these six items. You have the identification, it's actually called the transaction ID. Then you have a few flags, and then you have the number of question records, the number of answer records, the number of authoritative records, and the number of additional records. Now, these terms here are actually abbreviated using these codes. For example, the number of question records is usually QD count is used. For the number of answer records, AN count is used. For the number of authoritative records, we have N is, and for the number of additional records, we have AR count. So this is the format of the header that goes into this area. Then let's go to the flags field. So, and this part here. So this flags field is composed of these several items. The first one is Q. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So this is a 16-bit flag field. 16 bits. So the first bit here, this first bit here is the QR field. This means this actually tells us whether the type of the packet, right? Either is it a query or a response, depending on the value. So if the value in this field is 0, then it is a query. If the value here is 1, then it is a response. Then we have the opcode. So these are just some code to usually is query, by default is 0. And then you have other fields like AA for authoritative answer, TC for truncated answer, RD for recursion desired, RA for recursion available, AD for authentic data, these 3 zeros, and then checking disabled in this part of these 3 zeros, and then we have the R code, which is the reply code, right? And this is the interpretation of the R code, the reply code. So if the value of R code is 0, no error, 1, format error, 2, problem at name server. 3, domain reference problem. 4, we have query type not supported. 5, administratively prohibited. And the remaining bits are used, or the remaining values are reserved values. So that is for our code. And then for the query record format, so we have the query name, which is the name that we're trying to resolve, say example.com, and then we have the query type and the query class. So remember that we have here this question section here. So basically that's what we want. So query name, query type, and query class. So let's talk about the query name. So the query name format is something like this. So you have count, and then how many bytes for the succeeding, for the domain, let's say admin.atc.fhda.edu. Right? So count is admin, so 5 ADMIN, then count 3 ATC, count 4, etc. So that's the format for the query name. As for the query types, we have different types of queries. We can look for the A record, right? If you did your lab 8.com/137 before, we have the A record. So this is the actual IP address. We have the NS record, which is the name server. It identifies the authoritative servers for a zone. Then we have CNAME, which is an alias. Then the start of authority, which was the beginning of a zone, and other information that you would like to query. That means when you want to query something, right, you have to specify the type of the query. So usually by default, it is the A record. You're looking for the IP address given the domain name. And for the query class, right, the query class, so remember that our DNS server has different classes. Usually it is in for internet. The others are for other types of networks, but since we're using the internet, so usually the value for the query class is in. And the resource record, this is the resource record, which is the response here, right? Usually the response here. So you'll have these fields also. You have the domain name, we have the domain type, the domain class, the time to leave, the resource data length, and resource data. So we'll see more of this in the actual packet captures that you will see later. Okay, another important thing about DNS is the process of resolution. How is it that the given name is resolved to the IP address, or depending on the query type, right? So we usually have two approaches. We have the iterative resolution, and we also have the recursive resolution. In the iterative resolution, so we have the client. It will contact the DNS, local DNS server, let's say fhda.edu. It will contact that server. Do you have, let's say the request is for macgro.com. Do you have a record? Let's say, do you have the A record for macgro.com? It will contact this server. If no, then it will reply no, and then it will contact, it will tell the client, maybe you can contact the .edu server. So the client will send a request to the .edu server, and the .edu server will say, I don't know macgro.com, and then it will return the reply here, and then the client will send a request. Maybe you can look at the root server. So you can the client will ask the root server, hey, do you have macro.com in your A record? If not, it will, I missed the line here, but there should be a line here returning, I don't know that. Maybe you can consult .com since you are looking at macro.com. So the 6th part will be the response here. And then the 7th step, the client will send an inquiry, a request to the .com server. Hey, .com, do you know macro.com? The A record for macro.com? No, I don't. And then I missed again another line here is the response from macro.com. And then lastly, the client, .com will tell the client, maybe you can look at the server macro.com. Then finally, the client will get the IP address from macro.com. Okay, so that's the iterative resolution. As for the recursive resolution, this is what happens. So the client will ask the local DNS server for the university. So you have fhda.edu. Now fhda.edu does not know macro.com. So fhda.edu will ask the one above it, right? The one above the zone above it, which is .edu. Hey, that edu, do you know macro.com? That edu does not know macro.com. So that edu will ask the root server. So the main difference between iterative and recursive resolution is that the queries will be sent by the other servers, not directly by the client, unlike in the iterative resolution, where it is the client that consults the other servers. But here you have the local DNS servers or other DNS servers. They are the ones that contact the servers above them, that controls the domain or the zone above them, until eventually the result is obtained. So this is the path that is taken by the client. So you can just take note of the path to differentiate iterative and recursive resolution. Now let's talk about the dig utility, which is used to basically test the configuration. So here we have an example, dig www.example.com. So you can use the man command to do this, to run this command. For example, so you can just use man dig to get an idea of this utility, okay, what it does. So we have some samples here. And let's say in the example, we're going to dig at example.com. So dig example.com, or let's say www.example.com. And we're going to get this result because we are, by default, as I said, we asked for the A record. So this is the class, right? And this is probably the time to live. Right? So this is a user level tool to allow you to examine the resolution process, to view the resolution process. So you can add additional record like A, let's say NS. Right? So right, so there's no NS record for this. Right? CNAME, no CNAME record. Okay, so yeah, so the name and the type, right? So any. So I think that was any. So let's say, so usually there are other, if you don't specify a server name, it will simply return the A record. But if, let's say, you specify a server name, let's say let's use the Google server. So no record for any, but we have the A record, like for www.example.com. Okay, so now if this is the simplest way to use dig, and you can also use the plus trace command to be able to actually view the resolution process, right? So here you simply add the plus trace command, the plus trace option, to trace the actual resolution process for resolving www.example.com. So as you can see in this example, dig received 262 bytes from the local from this local server, okay, and then after that, so this dig consulted this local server and it returned these results, right? And after that, it got com, right? So this is and name server record. So we have the root server, and then we have the TLD server for the COM, right? A list of servers. And then after that, we have the example.com, and then the actual name server here. Right? This is the name server for example.com. And eventually, we get to the actual A record for www.example.com, which is 93.184.216.34. Okay, so that's the resolution process for example.com. It started looking at the root server and then at the TLD top level domain servers, right? For .com, for .com, and then example.com, and then finally www.example.com, which contains the A record. So you can actually try this. Let's say dig plus trace, let's say ics.uplb.ph. That's the resolution process. So dig will try to dig will first ask the local server, right? So what is this? Why is this local server contacted? If you recall our topic in ComSci 125, ComSci 137, we have /etc resolve.conf. So that is where this information is obtained. So it looked for the root servers, okay? And then it responded with this a list of the top level domains for .ph. Okay, so you have NS for APNIC, NS to that CUHK Hong Kong. Okay, so these are the name servers that host the .ph domain. And then we also have the .edu.ph. Okay, so these are also the name servers that host or that contains record for edu.ph, but they do not contain the actual record yet. So they're going to. So you will notice that this received from, right? So this received from will tell you which of these servers responded to the query. And then finally, we have UPLB. So UPLB, so that means you will notice that we have here Gomez.net.page. That means that Gomez.page.net referred us to this. So it has this record, right? It has this record UPLB, and eventually we have the NS record for, which is actually the name server actually where UPLB domain is being hosted is in Cloudflare for denial of service protection. So we have that, and finally Gomez.page.net also got this information, and then we now have the actual A record for ics.uplb.edu.ph. So it actually says here that ics.uplb.edu.ph is a CNAME. It is a CNAME. The actual A record is actually calabog.uplb.edu.ph, and this is the corresponding IP address, and the one that replied to us is the name server, meaning that the name server from Cloudflare is the one that contains the A record for Calabog. Okay, so you can. This is a very nice tool that will allow you to trace the path, the flow of the resolution process. So you can take advantage of that. Now we can also look. We can also use Wireshark. Okay? You can use Wireshark to capture the DNS resolution process. So I will not demonstrate it here, but here is a demo from the lab that allowed us to allowed me to capture the packet. So we have the first part here. This is the query part, and I've expanded the data field. So you have the transaction ID, as I mentioned earlier, the standard query, and this is the flags. Okay, the flags, and you will see that this one here is 0 because this is a query. Okay, and then we have the opcode of all 0, meaning this is the standard query, and the other fields, the meaning of other fields, the number of question records, the QD count, which is 1, and then the number of resource records, right? 0, authority resource record 0, additional resource record 1. So this is the query. So this is not the actual content. So this is, we only have one query. So this is the query. So we said that the format earlier, we have the domain name, the www.example.com. This is a type. We're trying to look for the IP address, and then we're looking for the class is the internet class. So this is the breakdown of that. And we have additional record. So this is also additional record, but we're not interested in that example. Now, this is the response, the capture of the response, the answer. Right? So you will notice that the flags. One thing to note here, as you do the lab, is that they should have the same transaction ID. The query and the response or the answer should have the same transaction ID. So this is 0xEFD1. This one should also, the response, we should also be 0xEFD1. But this one is the response. So we have the flag one here, and then other interpretations. We have one question. We have one resource record for the answer, authority records or the name server 0, and additional resource record 1. So this is the query, which is the same as the original, and then this is the answer. Okay, so can use Wireshark to capture the packets.